Hello, I will show you the M8190 arbitrary waveform generator generating a digital modulation signal at 1.76 gigasymbols per second at an IF frequency of 3 gigahertz. In order to generate our signal, I will use a MATLAB script that allows me to generate various kinds of IQ and RF waveforms. I will choose the digital modulation button, which brings up a dialog that allows me to set the parameters for my modulation. I change the symbol rate to the desired value of 1.76 gigasymbols, and by default the script will use an oversampling factor of 4, which results in 7.04 gigasamples per second sample rate. Because I want to use a carrier offset, an IF frequency of 3 gigahertz, I have to increase my oversampling rate so that I get to a higher sampling rate, which is 10.56 gigahertz right now. At that frequency, I can choose an IF frequency of 3 gigahertz, and for the purpose of this demonstration, I will use a QAM 64 modulation scheme. All the other parameters will stay at their default values. Now I can download the signal into the arbitrary waveform generator, and we will use the VSA software to look at the signal. This is just a spectrum of it, but what I'll do now is click on the Calibrate VSA button, which will communicate with the software, and as you can see, the setup is changing automatically, and the MATLAB script sets up the VSA software for the correct parameters. It will also turn on the equalizer of the VSA software to compensate for any frequency response in the channel. And as you can see in this display, there's some attenuation towards higher frequencies, which are compensated by the equalizer. Now, once I have optimized my setting, and I'm not quite there, I have to look at the range to make sure it's just outside of overload, which we are right now. Once the equalizer has stabilized, I can click OK in my MATLAB script, and then the MATLAB script will read the configuration from the equalizer and calculate this channel response into the data as a pre-distortion. It then downloads the data again into the arbitrary waveform generator, and now notice the equalizer has been turned off, and we still have a very good EBM result for this very wideband digital modulation signal at a 3 gigahertz IF. If desired, you can click the recalibrate button to even further improve the performance. In this case, we might not be able to get down any further. As you can see, with the already corrected signal, the equalizer now shows only very, very small deviations from the nominal performance. And if I click OK, the equalizer is turned off again. And in this particular case, we only have a slight improvement. And now the signal without the equalizer, once it has stabilized, achieves a performance of about 1.6%.